So, today we're going to tackle something called Process Safety Management, or PSM for short. Now, this is a critical OSHA regulation, but it's so much more than just a dusty rulebook. Think of it as the entire system, the whole shebang, designed to prevent really, really bad accidents at industrial plants. Let's jump in.
Let's start with a big question, right? You see these massive, complex chemical plants. What's the invisible shield that stops a normal Tuesday from turning into a full-blown catastrophe? Because the stakes, well, they couldn't be any higher.
And the answer to that question is Process Safety Management. It's the official OSHA framework, kind of like a master game plan for handling processes that involve some seriously hazardous chemicals. The goal is simple, but it's absolutely vital. Stop catastrophic spills, fires, and explosions before they can even start.
Okay, so to really get our heads around this thing, we're going to break it down into 5 main chunks. First, we'll talk about why this matters and who it actually applies to. Then, we'll get into the foundation, knowing your risks. After that, it's all about the people. Then, the daily playbook they use. And finally, how this whole system is designed to learn and get better over time.
So, Section 1. Why does process safety matter? Before we dive into all the nuts and bolts, we really need to understand who this is for. What kind of facilities and what kind of materials are we even talking about here? Well, PSM isn't for every single business out there. It's very targeted. The rules really kick in when you hit certain big league thresholds, like if you have a huge amount of a specific dangerous chemical, or you're working with more than 10,000 pounds of super flammable stuff, or if you're literally making explosives. It's all about the scale of the potential danger. And, just as important as who is covered is who isn't. So your local gas station, they're not covered. The standard specifically exempts places like retail stores, oil and gas drilling sites, and certain fuels that are just being used on site. This really helps focus the regulation on those high-risk industrial plants.
The entire PSN system is built on these 14 core elements. And these aren't just a random to-do list. They're designed to be completely interconnected, like gears in a machine, all working together to create this massive safety net. We're going to touch on these throughout our talk, starting right now with the foundation.
All right, let's move on to Section 2, where it all begins, the foundation. Think about it. You can't possibly manage a risk if you don't understand it, right? So these first elements are all about creating a super detailed blueprint of every single potential hazard in your facility.
This whole foundation really rests on 2 main pillars. First, you have to gather every single piece of information you possibly can, because you can't protect against what you don't know. And then you take all that info and you systematically analyze it to figure out what could go wrong. It's about turning that raw data into a real-world risk assessment.
And the level of detail here is, wow, it's immense. We are talking about everything. You need to know the toxicity of your chemicals, you need to have exact diagrams of your process flow, and you need the engineering specs for every single piece of equipment, all the way down to the individual pipes and safety relief valves. You have to have the complete picture.
Okay, so once you have all that information, you do what's called a process hazard analysis, or a PHA. This is a huge team effort with engineers and the folks on the floor, where you basically brainstorm everything that could possibly fail. And this is not a one-and-done kind of deal. Things change, equipment wears out, so this entire analysis has to be redone from scratch at least every 5 years.
Section 3, the people. Let's be real, a perfect safety plan on paper is totally useless if the people actually doing the work aren't involved, trained, and empowered. This part is all about the human element, which is so often the most critical piece of the whole safety puzzle.
So the people-focused elements really come down to 3 big things. You have to get your own employees actively involved. You've got to provide serious, ongoing training. And you need to make absolutely sure that any outside contractors on your site are playing by the exact same high-stakes safety rules.
OSHA is really clear on this one. The people who are hands-on with the process every single day, the operators, the maintenance crew, they must have a seat at the table. Why? Because they have that invaluable, real-world knowledge of how things actually work and where the hidden dangers are.
You know how it is. Over time, skills can get rusty and knowledge can fade. That's why that initial training just isn't enough. Every single person involved in a process covered by PSM has to get refresher training at least every 3 years. It's all about keeping that safety mindset sharp.
Okay, moving on to Section 4, the playbook. So we've got our information, we've got our trained people.
This is where all that analysis and training gets translated into concrete, day-to-day rules and procedures that make sure work gets done safely every single time.
These are basically the rules of the road for the plant. We're talking about crystal clear operating procedures for every possible scenario, a solid program to keep equipment in tip-top shape, special permits for high-risk jobs like welding, and a really formal process for managing any changes, big or small.
Let's just zoom in on that last one for a second. Management of change, or MOC. This is a super disciplined process for any change. Before an engineer can just swap out a valve or an operator can tweak a setting, that change has to be justified, its impact on safety has to be analyzed, all the paperwork and training have to be updated, and then it has to get formally approved. This stops a seemingly tiny adjustment from accidentally creating a massive new hazard.
And that brings us to our final section, the system for learning and improving. See, a PSM program can't just be set in stone and forgotten. It has to be a living, breathing system that's constantly checking itself, learning from its mistakes, and getting stronger and safer over time. PSM has two really key ways of checking up on itself. There's the Pre-Startup Safety Review, or PSSR. Think of this as the final triple check on a brand new process before it goes live. Then you have compliance audits. These are like a routine checkup every 3 years on an existing process to make sure everyone's still following the rules and that the rules are still working.
But what happens when something does go wrong? Well, the rules for investigating are incredibly strict. Any incident that did result or even could have resulted in a major release has to be investigated, and the clock starts ticking immediately. That investigation has to begin within 48 hours. The goal here isn't to point fingers or assign blame, it's to find the root cause so you can make sure it never, ever happens again.
And finally, this last element tackles a big question. What about a company's trade secrets? Can they hide critical safety info to protect their secret formula? OSHA's answer is a hard no. Safety comes first. Companies have to make all the necessary information available to their team. Now, they can ask people to sign a confidentiality agreement, but they can never, ever use trade secrets as an excuse to keep people in the dark about hazards.
So if you take one thing away from all of this, let it be this. Process safety management is not a binder that sits on a shelf collecting dust. It is a dynamic, living, interconnected system. It's the constant dance between good information, well-trained people, and disciplined procedures, all working together to keep very hazardous processes under control.
Which, of course, leaves us with one final thought to chew on. Let's say you could design a technical system that was absolutely perfect on paper, every valve accounted for, every procedure flawless. What is the single biggest risk that still remains?